was a homework question. This is from homework 11, problem 5. So this week, a very large running race occurred in Denver. The times were normally distributed with a mean of 21.38 minutes and a standard deviation of 2.7 minutes. So what percent of runners took 22.735 minutes or less to complete the race? Now, you don't have to draw this every time, but it's a nice reminder that when we say things are normally distributed, right, the distribution looks like this with sort of our main mode in the middle where the mean is. So this would be 21.38. And then we could go out 1, 2, 3 standard deviations on this side. We could go out 1, 2, 3 standard deviations on this side. I'm not going to add that right now because decimals. And so this question, when we say what percentage took that time or less to complete the race, right? This is a number, 22.73, that's somewhere about here, right? It's not a full standard deviation bigger. It's sort of in the middle. And so when we say what percent of runners, we're really starting to talk about this area here. What's the area that's less than 21.38 on this graph? So we can use our calculators to figure that out, and we do normal CDF, which takes 4 ingredients. Okay, and those 4 ingredients are the smallest number, the biggest number, the mean, and the standard deviation. So the mean and standard deviation are just given to us in the problem. So the mean is 21.38 and the standard deviation is 2.71. Now the smallest and the biggest numbers we got to think about a little bit more. We can just see that the biggest number, sort of the top of this shaded range, is 22.73. Remember I drew this line at 22.73. This was for the mean, which is right there. Okay, so the biggest number I'm interested in is 22.735. The smallest number I'm interested in is somewhere way down here. So you can either use 0. Some people like to think of negative infinity being the smallest race, but can you run a race faster than 0 minutes? No. These end up being the same because you can't run a race that's shorter than 0 minutes. If you are using negative infinity on your calculator, that's negative 1 E99. But I think 0 is a little easier. Now, in the second part of the problem, so this is part B, we're supposed to figure out what time in minutes is the cutoff to be in the fastest 82.89% of people. So it's sort of a backwards problem, right? This one, we get the percent of people who correspond to that time. Now we're going to go from a percentage, right? We know what the percentage is, and we want to go back to the time cutoff. And there's a function in our calculator that does exactly that. We want inverse norm. It's in the same menu as normal CDF. And again, there are videos in the quiz about how to use each of these, or in our class quiz about how to use each of these functions. But for a reminder, inverse norm takes 3 pieces of information. I'm going to explain each of them, but the mean and the standard deviation are the same. So that part we're just going to copy is 21.38 and 2.71. For the area, what we're saying is what area or percent is below. Okay, so if we're going to be in the fastest 82.89% of people, what that means is the area below us is 0.8289. And so if I put these 3 ingredients into inverse norm, I'll get the correct answer. For C, I'll leave C to you, but I'll give you a hint. For C, what percent of runners took this or faster to complete the race? We're going back to normal CDF, except we're going to be shading in a different part of this graph. So we're going to flip what's the smallest and what's the biggest in that case.